Hello students, let us go through some MCQs now. The MCQs are really simple. It would be a kind of revision of what we have already done, right? So let's do it. The question is choose correct alternatives for each of the following questions. The very first question is to draw the graph of 4x plus 5y is equal to 19. Find y when x is equal to 1. Very easy, right? We already know the value of x. We are supposed to just find the value of y. And how do we do it? By substituting x is equal to 1 in the given equation, right? So let's do that. The given equation is 4x plus 5y is equal to 19. Let's substitute x is equal to 1. We get 4 into 1 plus 5y is equal to 19. We get 4 plus 5y is equal to 19. Variables on one side, constants on the other side. We get 5y is equal to 19 minus 4, that's 15. We get y is equal to 15 upon 5. Y is equal to 3. So B is the correct alternative. In the exam, it is better if you show the calculations because you any which ways will be doing the calculations. So even if you show, it's nice, right? It's better. Let's move on to the next thing. The question is for the simultaneous equations in variable x and y, dx is equal to 49, dy is equal to minus 63, d is equal to 7, then what is x? Kramer's rule, right? How to find x when dx and d is given? We just need to use the formula by Kramer's rule, x is equal to dx upon d, right? Dx the value is 49, d value is 7, so it is 49 upon 7 which is equal to 7. 7 is the alternative A. As I said, calculations, if you show, it is better in the exam. Let's move on to the third question. This time it is the find the value of the determinant. A determinant is given to us. We just need to find the value of it. How we used to do it? Simple cross multiplication with a minus sign in between, right? So let's do that. What we get? We get 5 into minus 4 in a bracket, minus sign, and then 3 into minus 7 in the next bracket. 5 into minus 4 is minus 20, then a minus sign, and 3 into minus 7 is minus 21. So it's minus 20 minus of minus 21, that's minus 20 plus 21. So minus 20 plus 21 is 1. So your correct alternative is D, right? Let's move on to the next MCQ. The sum is to solve x plus y is equal to 3 and 3x minus 2y minus 4 is equal to 0 by determinant method find D. Again, we know how to find D. Two columns, the first column would be the coefficients of x and the second column would be the coefficients of y. So let's do that. The first equation is x plus y is equal to 3. Second equation, you'll have to rearrange a bit, variables on one side, constants on the other side. So it's 3x minus 2y is equal to 4. Now let's form D. D, the first column would be the coefficients of x, that's 1 and 3. The second column would be the coefficients of y, that is 1 and minus 2. Now let's cross multiply. What we get? 1 into minus 2 minus 1 into 3. 1 into minus 2 is minus 2, minus 1 into 3 is 3. So minus 2 minus 3 is minus 5. D is equal to minus 5. So C is the correct alternative, right? Now before we move on to the next MCQ, there is a concept that we all should know. What exactly it is? Let's see. Now say I give you two equations, x plus y is equal to minus 3 and x minus y is equal to minus 1. And if I ask you all to solve it, I am sure you will add the two equations and you will be easily able to get the values of x and y. So after solving, after adding the two equations, you will get x is equal to minus 2 and you get y is equal to minus 1, right? Now remember one thing, students, this minus 2 comma minus 1 is the only solution which will satisfy both these equations. Individually, if you all remember, a linear equation in two variables has got infinite number of solutions, right? We learned this during the graphical method. But when we solve them simultaneously, the answer that we get is unique solution. That is, this is the only solution which is common to both. There is only one point of intersection of two lines, right? So this is a case, a normal case where the equations have got unique solution. When I say unique solution, one common solution for both these equations, right? You solve it by any method, the answer will be minus 2 comma minus 1. Even if you solve it by graphical method, the lines will be intersecting at the point minus 2 comma minus 1. You use any method, equating the coefficients, substitution method, graphical method, Kramer's rule, any method, this will be the answer, -2 comma -1. So that is case 1, equations with unique solution, right? Now let me just give you two more equations, 2x minus y is equal to 1 and 2x minus y is equal to 4. Now you try to solve it. To solve it, you will have to subtract it, right? Because even the coefficient of x is the same, coefficient of y is also the same, and the signs are also the same. So you need to subtract. When you subtract both the equations, when you subtract say 2 from 1, what happens when you change the signs and all? 2x minus 2x gets cancelled, minus y plus y also gets cancelled. So this is a condition where both the variables are getting cancelled and we are getting some weird 0 is equal to -3 or something of that sort. So what do? We are not able to solve it, right? You try to solve it by any method, you will not get the answer. So these are the equations. This is an example of the simultaneous equations which have got no solution at all. You try to solve it by any method. You try to solve it by graphical method, both the lines will be parallel to each other. So this is case 1 where the equations had unique solution. This is case 2 where the equations have got no solution. There is a third case. Now this is an equation in front of you, x minus y is equal to 2. Let this be the first equation. Now I ask you to multiply this equation say by a number, say 2. So what you get is 2x minus 2y is equal to 4, the next equation. Now think about this. Are these two equations same or are they different? They may look different, but they are actually the same. Because what we have done, we have just multiplied the equation by 2 and we have got this equation. You will divide this equation by 2 and you will get the first equation. So basically, the two equations may look different, but they are the same equations. We have just modified equation number 1 to get equation number 2. Now because they are same equations, they will have the same set of points, the same set of the values of x and y which will satisfy them, right? So basically what I am trying to say is this is like one linear equation in two variables, and a linear equation in two variables always has infinite number of solutions. So this is a case where the equations have got infinite solutions, and because the set of points are also the same, if this is x minus y equal to 2, this will be 2x minus 2y is equal to 4. So both the lines are also overlapping on the graph paper, right? So basically these are the three different types of simultaneous equations, as you all can see. The first case is equations with unique solution or one common solution where the lines are intersecting on the graph paper. Then the second is the equations having no solution where the lines are parallel on the graph paper, and the equations with infinitely many solutions where the lines are overlapping on the graph paper. Now you may get a question in the exam where you will be given such equations and they will say, without actually solving, state whether the equations have got unique solution or no solution or infinitely many solutions. Now how do we do that in the exam? If such a question comes that without solving we are supposed to tell whether the equations are of unique solution type or no solution type or infinitely many solutions type. So for that the simple technique is use our Kramer's rule, that is find the value of d, find the value of dx. Just find d, just find dx, and you will get to know whether the equations have unique solution or no solution or infinitely many solutions. Now the question is how? How do we find? What do we get in d dx so that we come to a conclusion? How do we come to a conclusion, right? So remember, if you try this, you can try this at home, you can just solve it, you can find the value of d. In the first case, you will get some value of d. In other words, you will get d is not equal to 0. Okay? So always remember this. You take any sum. In any sum where d is not equal to 0, the sum will always have unique solutions. So always remember this. For equations to have unique solutions, d should never be equal to 0. You can try it out. You can try, you know how to find d. Just try out. Try to find the value of d. You will get some value of d. So d will not be equal to 0. It can be positive, it can be negative, it can be any other real number. But d should not be equal to 0. So always remember, find d, and if d is not equal to 0, we can come to a conclusion that the equations will have unique solution, right? Now what if d is equal to 0? If d is equal to 0, then it can either be no solution or infinitely many solutions. When d is not 0, you find d if such a question comes in the exam. If d is not 0, we come to a conclusion straight that equations have unique solution or one common solution. But if d is equal to 0, it can either be no solution or infinitely many solutions. So, how do we differentiate between a no solution case and an infinite solution case? So, check whether it's a no solution case or an infinite solution case, you need to find the value of dx. If d is 0, but dx is not equal to 0, then it is no solution. You can check it yourself. The equations are there in front of you, find d. You will get d as 0. Then find dx. Dx will not be equal to 0. So, if d is 0, but dx is not 0, you come to a conclusion that the equations will have no solution. And if d is 0 and dx is also equal to 0, then you come to a conclusion that the equations have infinitely many solutions. So, these are the three conditions that you need to remember. If d is not equal to 0, your conclusion is equations have got unique solution or one common solution. If d is 0 but dx is not 0, then no solution. If d is also 0 and dx is also 0, then infinitely many solutions. Clear? Now, our next MCQ is based on this concept, because the question is ax plus by is equal to c and mx plus ny is equal to d are the two equations given, and an is not equal to bm, then these simultaneous equations have only one common solution, no solution, infinitely many solutions, and only two solutions. Only two solutions not possible at all, right? So, whenever you have a sum like this, what is our approach? We should start with the finding of d. So, let us find d. You have the two equations where variables are on one side, constants are on the other side, and it is in the alphabetical order, right? So, let us find d. D, first column are the coefficients of x, that is a and m, and the second column are the coefficients of y, that is b and n. So, let us find d. We get d is equal to an minus bm. Okay. Now, while just looking at an minus bm, we cannot come to a conclusion that whether d is equal to 0 or not equal to 0. So, for us to come to a conclusion, they have given us a condition, as you all can see, that is an is not equal to bm. So, can we say when an is not equal to bm, shift this bm to the other side, we get an minus bm is not equal to 0. So, what are we getting? An minus bm is not equal to 0. What is d? An minus bm, and what are we getting? An minus bm is not equal to 0. So, can we come to a conclusion that d is not equal to 0, right? Now, because d is not equal to 0, we come to a conclusion that the equations will have one common solution. So, always remember this. Whenever you have a question like this, use our method which we used to use in Cramer's rule, find the value of d. If d is not equal to 0, you come to a conclusion that it will have only one common solution, right? And if d is equal to 0, then check with dx. If dx is not 0, then no solution. If dx is also equal to 0, then infinitely many solutions. As simple as that.